Hello all. In this video, I'll explain about principle of mathematical induction. Mathematical thinking can be done in two ways. One is deductive reasoning, one is inductive reasoning. In the case of deductive reasoning, what we do here is it's a kind of general case to a particular case. Like if you have a formula of a minus b whole square equal to a square plus b square minus 2ab, then that's a general formula. It holds for all real numbers. You can take the same formula for particular cases like a equal to 3, b equal to minus 4. No need to verify that formula for 3 and minus 4, as it is proved for general case. It will hold for these particular real numbers also. But in the case of inductive reasoning, it's a kind of generalization from a particular case. It's like, suppose if you have the sum of first n odd natural numbers like 1, 1 plus 3, 1 plus 3 plus 5, 1 plus 3 plus 5 plus 7. So 1, this is 1, 1 plus 3 is 4, this is 9 and this gives you 16. Now look at all these values. They are all perfect squares. 1, 2 square, this is 3 square, this is 4 square and so on. So these are all particular cases. By looking at all these particular cases, we can have a generalization that the sum of first n odd natural numbers is always a perfect square. 1 plus 3 plus 5 plus so on up to 2n minus 1 is equal to n square. So that kind of reasoning process is called as inductive reasoning. So in the case of inductive reasoning, it's a generalization from a particular case, whereas in the case of deductive reasoning, it is a general case to a particular case. The main motivation behind inductive reasoning is that you can have one illustration. Suppose you have a pile of books. The books are placed in this way. Now, if you go and push the first book, what is going to happen? All the books will fall. Now, to make sure that all books will fall, what you have to do is you have to check whether the first book falls. If that happens, then only the rest all books will fall. And one more thing is, if first book falls, there is no guarantee that all other will fall. So what you have to do in the general case is, if any book falls, its successor will necessarily fall. If you make sure that, like any book in middle, if falls, its next book will definitely fall. If you do that, then you can conclude that all the books will fall. This is the main motivation behind the principle of mathematical induction. Now let me state what is the principle of mathematical induction. That suppose you have a statement, that statement is named as P of n. This statement contains a natural number. Means it's a statement having natural numbers. Then first condition is P of n should be true, and the second condition is if P of k is true for some k, it is some natural number in between, then it will be true for its successor also. P of k plus 1 is also true. If this happens, then we can come to the conclusion that the given statement is true for all natural numbers. Let us take one example to illustrate how the principle of mathematical induction works. So one first problem is show that 1 plus 2 plus so on up to n is equal to n into n plus 1 divided by 2 using the principle of mathematical induction. So what I am doing here is take the given statement as P of n. P of n is 1 plus 2 plus so on up to n equal to n into n plus 1 divided by 2. Now first condition you have to verify, is it true for n equal to 1? So P of, put n equal to 1 here, 1 which is equal to 1 into 1 plus 1 divided by 2, that gives you equal to 2 by 2 which is equal to 1. So LHS equal to RHS, hence P of 1 is true. Now second condition, you have to assume that P of, this is a very important step in the case of proving a statement using principle of mathematical induction. You have to assume that this statement is true for some k, and you have to prove that it is true for next number, that is k plus 1. So let's assume, let us do the assumption P of k is true. 1 plus 2 plus 3 so on up to k. Replace n by k is equal to k into k plus 1 divided by 2. Name this as equation 1. Now to prove P of k plus 1 is true. Now to prove P of k plus 1 is true, what you have to do is first write what is P of k plus 1. So P of k plus 1 is nothing but replace n by k plus 1. So 1 plus 2 plus 3 so on up to k plus k plus 1, one extra term, previous term is k, is equal to, replace this k by k plus 1. K plus 1 into k plus 2 divided by 2. So this you have to prove. Now to prove this, you consider the LHS. There are other methods also. Few people will take this and they add k plus 1 on both sides and they do the simplification. That's also right. What I do here is, let me write what exactly you want to prove, then take LHS from that, then make the simplifications. So first 1 plus 2 plus 3 so on up to k, this can be replaced by k into k plus 1 divided by 2 using the first equation. Then this term remains as it is, plus k plus 1. So next you have to take LCM. LCM is 2. This LCM multiply, take LCM 2, 2 into k plus 1, k into k plus 1 is equal to, now do the simplification, k square plus k plus 2k plus 2, k plus 2k, it is 3k plus 2 whole divided by 2. Now this factorization, if you factorize this, it gives you k plus 1 into k plus 2 divided by 2. Now we have already written here what exactly I want to prove. So that we obtained here the RHS. Hence you can write p of k plus 1 is true. So what we obtained here is p of k implies p of k plus 1. Both the conditions of principle of mathematical induction are satisfied here. Hence we can come to the conclusion that therefore by the principle of mathematical induction, p of n is true for all n belongs to n. So the main intention behind this is a statement containing only natural numbers, and this statement, the validity of this statement is verified using the principle of mathematical induction. Let us take one more problem. Show that 1 cube plus 2 cube plus so on up to n cube is equal to n into n plus 1 divided by 2 whole square using the principle of mathematical induction. So this is sum of first cubes of first n natural numbers and its formula is given by this. Let us go for the proof by the principle of mathematical induction. As before, take the given statement as p of n. Now you have to verify the first step. For n equal to 1 cube, only this term comes, 1 cube equal to 1 into 1 plus 1 divided by 2. 2 plus 1 is, it is 1 plus 1. 2 by 2 it is 1. 1 square is 1. So LHS is equal to RHS. Hence P of 1 is true. The statement is true for n is equal to 1. So next you have to assume that the statement is true for some k, that is nothing but 1 cube plus 2 cube plus 3 cube plus so on to k cube equal to k into k plus 1 divided by 2 whole square. Now name the statement as equation 1, because we are going to use this particular equation in the next step. Now we have to prove p of k plus 1 is true. Now to prove p of k plus 1 as true, what you should do is write what is p of k plus 1. So you will get an idea what exactly you are supposed to prove now. 1 cube, 2 cube plus 3 cube so on up to k cube plus k plus 1 whole cube equal to, replace k by k plus 1. That's what you have to do. In the case of p of k, replace n by k. In the case of p of k plus 1, replace n by k plus 1. So k plus 1, k plus 1 plus 1, so it is k plus 2 divided by 2 whole square. Now consider LHS of this. 1 cube plus 2 cube plus 3 cube plus k cube plus k plus 1 whole cube. Now the first k terms can be replaced by k into k plus 1 divided by 2 whole square. That's from the equation 1. Plus remaining is k plus 1 whole cube. Now take LCM. LCM is not 2 here because 2 gets squared. So 2 square here. 4 is the LCM. Now k also gets squared. K square and k plus 1 whole square plus k plus 1 whole cube. Now take the LCM. After taking the LCM and simplifying these terms, so k plus 1 whole square is common. Take that k plus 1 whole square outside. So k square plus 4 into k plus 1 divided by 4 is equal to k plus 1 whole square. This can be simplified as k square plus 4k plus 4 divided by 4. So that is k plus 1 whole square into, this is a square plus 2ab plus b square, that formula, k plus 2 whole square divided by 4. Now that is the required RHS. We have already written here. K plus 1, k plus 2 divided by 2 whole square, that is nothing but k plus 1 whole square into k plus 2 whole square divided by 4. Therefore, we come to the conclusion that p of k plus 1 is true. This is true because we assumed p of k is true. So that's why we write here p of k implies p of k plus 1. If this is not true, then definitely we cannot prove p of k plus 1 is true. So it is kind of induction. So that means that it gives you the momentum. The previous value will give the momentum. It transfers the momentum to the next successor, and next successor will transfer its momentum to the next successor. So that's how it gets induced, and it will pass through entire numbers, natural numbers, so involved in the given statement. Hence, we can conclude that therefore by the principle of mathematical induction, P of n is true for all n belongs to n. Why we have to verify this P of 1 is true? Because if 1 is true, by this characteristic, that is P of k plus P of k plus 1. So, if it is true for 1, its successor is 2. It is true for 2. If it is true for 2, its successor is 3, it's true for 3 also, and it continues. So, this is how the principle of mathematical induction works. I hope you understood the concept. Thank you for watching.